Hello everyone, my name is Shyam Chauhan and today we are going to cover exercise 1.2 question number 1 and question number 2. To prove this statement, we will do these steps, that is, given the statement, this is the statement, we will assume that the statement false, then we will try to prove the assumption wrong. And hence the assumption is wrong, therefore the statement is true. So let us start the proof. The statement is root 5 is irrational. We will assume that assumption is root 5 is not irrational, or we can say root 5 is rational. Because the root 5 is rational, we can represent root 5 as a divided by b, where a and b are integers. We have b not equals to 0 because the division of any number, let's say any number, by 0 is not defined. And we have a and b as co-prime numbers. I have made the detailed video on co-prime number. The co-prime numbers are those numbers which have the common factor as 1. For example, the co-prime numbers are 8 and 9. The factors of 8 are 1 and 2. Factors of 9 are 1 and 3. We can see that the common factor, that is only 1, and 1 is the common factor. We can see that not co-prime number example, that is 8 and 12. The factors of 8 are 1 and 2. The factors of 12 are 1, 2 and 3. We can see that there are two common factors. That is 1 and 2, and hence 8 and 12 are not co-prime numbers. Let us continue our proof. That is root 5 equals to a divided by b, that is equals to root 5b equals to a. Squaring both the sides, we will get 5b square equals to a square. We know that a and b are co-prime, That means only 1 is the common factor between a and b, and we can see that 5 divides a square. That means 5 is the factor of a square. And by theorem, we can say that 5 is also the factor of a. This means that I can write a equals to 5 into some another constant, let's say c, where c is integer. This is similar to, let's take one small example, that is 15. 5 is the factor, 5 is the one of the factor. That means I can write 15 equals to 5 into some another constant, that is c, that is equals to 5 into some another constant. In this case we have taken c, so I can write c here. So c is the integer, and we can write a equals to 5 into c. Now put a equals to 3c in this equation, that is 5b square equals to a square, where a equals to 5 into c. Because a equals to 5 into c. This is equals to 5b square equals to 5 square is 25 c square. Dividing both the sides by 5, you will get b square equals to 5 c square. Now 5 divides b square. This means that 5 is the factor of b square. And by theorem, we can say 5 is also the factor of b. Now if we see, we have assumed that a and b are co-prime numbers. We have assumed that a and b are co-prime number, and hence there is no common factor between a and b. But if we see here that 5 is factor of a and 5 is also factor of b. 5 is factor, or we can say common factor of a and b. But this contradicts the fact that a and b are co-prime numbers. And hence the assumption that root 5 is rational is false, and the statement root 5 is irrational is true. Now let's solve question number 2. Question number 2 is 3 plus 2 root 5 is irrational. We have to prove 3 plus 2 root 5 to prove 3 plus 2 root 5 is irrational. The steps that we will follow is, given the statement that is 3 plus 2 root 5 is irrational, we will assume the statement is false. Then we will try to prove the assumption wrong, and hence we can say the given statement is true. We can say in general that in any of these type of questions, we know that under root prime number is irrational, that is root 2, root 3, root 5, root 7, all these are irrational numbers. So we will try to bring of the form under root k, where we can say under root p, where p is prime number, equals to some rational number, say a by b, and then we will try to prove that if this is a rational number, we will try to prove that this is also a rational number, and we will conclude that this is not rational, and hence the assumption is wrong and the statement true. So let us start the question, that is, the question is 3 plus 2 root 5 is irrational. We have to prove that this is irrational. So the steps that will be, we will assume 3 plus 2 root 5 as rational. That means we can write 3 plus 2 root 5 of the form a by b, where a and b are integers, b is not equals to 0, and we have a and b as co-prime numbers. Then we know that this is irrational, so we will make root 5 as the subject, that is we will make the form 2 root 5 equals to a by b minus 3 and divide by 2, that is we have made root 5 as subject, that is root 5 equals to 1 divided by 2 in bracket a by b minus 3. Now we know that root 5 is irrational number. We will try to prove, and we have assumed that this is a rational number. So we will try to prove that this is not rational number. Hence the assumption that this is a rational number is false, and hence the given statement that 3 plus 2 root 5 is irrational is true. So let us start the proof. Given the statement that 3 plus 2 root 5 is irrational. We will assume that three plus 2 root 5 is rational, and hence we can write 3 plus 2 root 5 equals to a divided by b, where if a divided by b is rational number, that means a and b are integers. Then we have b not equals to 0, and we will assume that a and b are co-prime numbers. That is equals to 2 root 5 equals to a divided by b minus 3. This is equals to root 5 equals to 1 divided by 2 a divided by b minus 3. We know that because a by b is rational, this means that a by b minus 3 is also rational, and this implies 1 by 2 in bracket a divided by b minus 3 is also rational. If we have right hand side as rational number, this means left hand side is also rational. This implies root 5 is rational number. If the question is of 2 or 3 mark, then you can directly write that but root 5 is irrational number, and hence the assumption is wrong, and the statement three plus 2 root 5 is irrational is the statement is true. If the question is of 5 mark, then you have to prove that under root 5 is also irrational number. If we have root 5 as a rational number, that means we can represent root 5 equals to a divided, let's take some another integer, that is m divided by n, where m and n are integers. We have n not equals to 0, and we will assume that m and n are co-prime. If m and n are co-prime, that means the common factors between m and n is 1. This is equals to root 5 into n equals to m. Squaring both the sides, we will get 5n square equals to m square. M and n are co-prime, hence there is no common factor between m square and n square. But if we see here, 5 divides m square, so 5 is the factor of m square. Five divides m square. This implies 5 is factor of m square, and by theorem we can say 5 is also the factor of m. If 5 is the factor of m, we can write m equals to 5 into some another constant, let's say k, where k is any integer. This is similar to, let's take one small example, 25. We have 5 as one of the factor, so we can represent 25 equals to 5 into 5, that is equals to 5 into some another constant. This is similar to that. If 5 is the factor of m, that means we can represent m as 5 into some another constant. Now put m equals to 5 into k in this equation. Five n square equals to m square. We have m equals to 5 into k whole square, because m equals to 5 into k. We have 5n square equals to 5 square is 25 k square. Dividing both the sides by 5, we will get n square equals to 5 k square. If we see here, 5 also divides n square, that means 5 is the factor of n square. So we can write 5 is the factor of n square, and by theorem we can write 5 is also the factor of n. But this contradicts the fact that m and n are co-prime. This means that m and n does not have any common factor. But if we see here, 5 is the factor of m and 5 is also the factor of n. But this contradicts the fact that m and n are co-prime. Hence, our assumption is wrong, and the statement that is 3 plus 2 root 5 is irrational is true. In next lecture, we will cover question number 3. That will be the last lecture of this chapter. Thank you.